Okay, so can you see my screen? Okay, so today my topic of present. So by the way, I'm Rahil. My topic of presentation is BitTorrent. So I'm just gonna give you a brief overview of how this protocol works. So let's join the swarm and explore. So first of all, what is BitTorrent? BitTorrent is a peer-to-peer file sharing protocol used for distributing large amounts of data. So just to give you a comparison, on the left side I have a traditional client server model. On the right side I have a peer-to-peer network. So let's say you're downloading GTA 5. Of course, you won't be downloading it from Steam. Let's say you're pirating it. So you go to some website and start downloading the game. What happens in a traditional model is that there is just one server and you're downloading from there. And as number of clients increase, as number of people who download the file increase, the server is going to throttle. That means the server is going to serve the files a little in a little less manner. I mean, it doesn't. So the bandwidth decreases and you cannot download the files fastly. So that's the problem in client server model. So that problem is being peer-to-peer tries to fix that problem, wherein one person can download the file, and then from this person any other person can actually download the file. Now once these two people have the file, if the third person joins this network, he can download the file from person 1 and also from person 2. Now when these three guys have the file, if the other one joins the p2p network, he can download from the three other persons. So this is just a gist of how peer-to-peer networks work. What the advantage here is that there is no stress on one single server, and there is no single point of failure. If even one person fails to serve the file, the other two are present, and the bandwidth is also not decreased because lot of peers are serving that file. Okay, moving forward. So who, what, where, and when? Bram Cohen, who is the inventor of this protocol, released this protocol in 2001. If you want to read the specification, I have posted two beautiful links where one is the official research paper and the other one is the RFC implementation of that. Now it is maintained by Cohen's company, BitTorrent Inc. You might have heard of this software, BitTorrent. You usually heard of it as uTorrent, but the BitTorrent is the official one, which is also maintaining the BitTorrent protocol. Next, why? What is BitTorrent used for? Well, almost anything. It is used for content distribution, movies, music, podcasting, games, and a lot of other stuff. Coming to commercial use, this is quite interesting. Where this is used in game patching system. Just let me spend there a minute to explain you how that works. For example, let's say GTA 5 rolled out a patch for your game. Now once they rolled out a patch, what happens, because a lot of people play GTA 5, they cannot download it at a single time from the server. The server, as we discussed in the traditional client server model, the server throttles. Now to overcome that issue, what these gaming companies did was to use this peer-to-peer protocol, wherein if some people who can download from the official gaming website, if they can download the patch, the others can distribute that patch from the other peers who have already downloaded the file. I think you got it. So that's one thing. And also for programs, if you want to download a Linux image, let's say you want to download Ubuntu or something, you cannot host it because they are just open source, not Ubuntu, but let's say any other distribution. Ubuntu is a commercial image anyways. So if you have any other image, um, they don't have money to actually spend money on serving files, so they just throw it on torrent so that anyone can download it. So that's one interesting use case, and I've also added this little emoji. Nice. How BitTorrent works. So there are basically four terminologies which I would like to discuss. The first one is called seeds. A seed or a seeder is the one who actually hosts the file. So in this case, um, let's say if someone posts the movie or the game on the torrent, if he is the one who is initially doing that, that person is called a host. So his duties are to host file and also to distribute this file to the other peers, so that the other peers in the next level can be redistributed, right? And also he can determine the speed of the download on his bandwidth, right? This is the important point. The more seeds a torrent has, the faster transfer generally will be. Got this. And the next one is the peers. Peers in the sense we mostly. So what we do, our duty is to download the files and again redistribute it to the other peers. So I'll just tell you one more thing here. What happens usually is we download the files, but we do not redistribute it again. So if you've used torrent any time, what you just do it, you just download, and what you do to the upload speeds, you just remove the upload, so that you can just download the file and you cannot upload it. That's fundamentally a wrong thing. But given it is India, you cannot download it. Like if people have Wi-Fi, please do upload the files as well, right? uh, that's one thing. So leechers is nothing but, so if you're downloading the file but you're not redistributing it again, that is you're not allowing the other peers to download from your IP, then you're called a leecher, basically. And that like torrent communities don't like a lot of leechers on their servers. So you steal bandwidth from the other seeds, that is you download and do not contribute to the swarm. Ultimately you kill the torrent life. So torrents are only as healthy as they are available, right? And a leech kills the lifespan of the torrent. So don't be a leecher, guys. Anyone, if you please download a torrent file, please also try to upload it at least to some place. Next, trackers. So three concepts: seeds, peers, and leechers has done. The next concept that I want to discuss is trackers. So what happens is a seed should be able to post this somewhere, right? Like how does peers know where the file is there? Like how does they know the IP address? So what seeders will actually do, is they go to this tracker and they put down a torrent file which has all the information about your your torrent, your file, right? So for example, just to take an example so that you can easily understand this, a tracker could be anything like a kickass torrent. You might have heard of this. So it's not a tracker in the sense, it's not even a tracker. It acts as both tracker and a server. So you can also directly download the torrent files and also use it as a server to host all of the seeds which you have with you. So right, as a seeder, you will post them to a tracker, and that tracker will be distributing. Like any any computer which has the link to tracker, which have the link to the tracker, can access the tracker and download the torrent file from there, and also connect to it to we'll just come to that later. You get the basic gist, right? That's tracker. So internals. So just basic internals, I guess. I hope you understand this. It's a very easy. So first of all, what you do, you have to first download the torrent file, right? Now to download the torrent file, the first step is to find the seeds or other peers first, right? You have to find who is actually hosting the file, or at least the other peers who are having the file. Now for that, you can actually go to a tracker or a central server. Tracker is not a correct word to use here, but tracker or a central server, you can go there and you actually can download a .torrent file. These days you don't need a tracker, you can download the torrent file from anywhere, right? .torrent file from the tracker. Once you have the .torrent file, it's just like any other .json or .yaml file format. It's just encoded in a bean code format. Now what you have to do is this: you have to parse this or unmarshal this file to get all the details. Now this .torrent file contains different details. So one of the details is the tracker URL. So tracker URL in the sense, yeah, this is the tracker URL where you can go and get the IP addresses of the different peers. We'll get to that, right? And also timestamps of when the file got created or when the file got deleted. For this example, let's take GTA 5 game. Now the name of the requested file, SHA-1 hashes of each piece. What is a piece? So piece basically is like you have a very big file, right? Just give me a minute. So we had a very big file. Now, if you try to download the very big file from one server itself, one peer itself, then it will take a lot of time, right? So what this peer-to-peer model tries to solve is that you can you can download a little piece from that whole file. You cannot, like, there is a way you can directly request for the whole file, but also you can also request for a small piece from the from the big file, right? So that is a piece. Now here's the magic. You can download different pieces from different peers and finally stitch them together so that they are in order to get the big ordered file, right? So yeah, so like, and each piece needs to have integrity, and that's why we split that piece, and we also have a sha1 hash of that. Now how do we do this splitting and all this stuff? That is done near the seeding. If you want to get into more details, you can just go to the RFC and read about it. I'll just give you a basic gist. Okay, so finally, once we have all this information, we will talk to the tracker. Talking in the tracker, in the sense, we have to announce ourselves. We have to say that, like, whenever you are participating in a torrent network, you have to also make yourself as a peer. You'll have to announce yourself. So you'll announce yourself with a peer ID. This can be any random 20 byte peer ID which you can generate, and then in response, the tracker will send you a peers list which will have all of the peers which are having that file partially or fully. It also gives peers which have partial files, because you can download a piece from it anyways, right? Yeah, so that's why. Finally, when once we have the peers list, once we have the IP addresses of the peers, what you can do is you can start a TCP handshake with an individual peer, complete the handshake, and also check if the peer is in choked or unchoked states. So on the peer side also, what you can do is you can announce yourself as choked or unchoked. If you announce yourself as choked, you cannot transfer the file. I mean, the peer cannot transfer the piece. Now if it is an unchoked state, only then we can request to it and receive the file. So if it is an unchoked state, we proceed further and request for the pieces, download the pieces, and finally stitch the downloaded pieces from the different peers which we received. And bit fields for efficient tracking of downloaded pieces. Well, like, how do you know how, where, like, which pieces got downloaded? We basically maintain an array of bits which you can check. Like, if the bit at that particular location is set, then you have the file, like you have that piece with you, or else it is, if it is not there, you go to that any peer and get that file. And final step, a very important step, is to parallelize this last step. So parallelizing here in the sense, you have to download from multiple peers, and that is to download small pieces from different peers and finally stitch them up so that you can ultimately speed up the process. So just to give you a flowchart of this, so this is just how you connect with a peer. Start a TCP connection, do a handshake, and grab a piece of work from the work queue. So we use queues to download files which we want. And if the peer have this piece, then we attempt to download this piece. And once the piece is downloaded, we check the integrity comparing with the hash which we had in torrent file. You remember we had this SHA1 hash here. So that SHA1 hash, we will compare it with the downloaded file. And once it is downloaded and hashes match, we send it to the result channel, and that result channel will finally combine the whole pieces. Now, if it is not, like, if the peer doesn't have the piece or hashes doesn't match, we put back that piece, requested piece, again in the queue so that we can download it again. Put back in the queue, in the sense, put back the ID of that particular piece. Now, if there is a network failure, we put the work back on the queue to retry, close the connection, and kill the thread. So I forgot to add the thank you slide. Okay. Anyways, that's it, guys. I hope this was useful. I know it was a little funky, but that's how I can come up with for a small session. So, thanks. Anyone have any feedback? Yeah. Sure. Yep. Yeah, that's what the sharing and caring means. It's just your choice to download it or not. You download it again, run through a scanner or something. That's there. The thing of security is it's definitely there. You have to think about it when you're using torrent, of course. So, well, of course, I mean there is, I mean, Sripriya, there is always this hash which you have already, so we can cross check it. We have the SHA-1 hashes, you remember, which are in the torrent file. If anyone modifies that, no, and if anyone tries to modify that piece, that hash will not match, and we will discard that piece downloaded. So that's one integrity check we are doing. But anyways, like, anyone can do a man in the middle attack. He can directly send in the entirely a different file. So that's definitely possible. That's there. Any other feedback or questions? Yes. Cool.